Welcome back, AP Stat. This is Chapter 8, Regression Wisdom. So we're going to start by exploring patterns in residuals. We learned in the last section that patterns in residuals are not a good thing. And we're going to look at an example of a residuals plot gone wrong. So as we've seen before, observing the residuals can help us understand patterns in our data that might be hard to see otherwise. Our data might look perfectly fine, but a residuals graph might reveal that a linear model is not the best. So we're going to consider the data below featuring a sample of penguin dives of various time intervals. So we have on the x-axis the duration in minutes of the dive, and on the vertical axis, the y-axis, we have the dive heart rate in beats per minute. And these seem to show some kind of association between the duration of a dive, how long the penguin is underwater, and the heart rate during the dive. So what seems to be the nature of this association? Well, in terms of strength, it's moderately strong. In terms of the direction, it is definitely it's definitely going down, and so we've a negative direction. And possible outliers, these points do seem to follow a pattern, and that pattern is non-linear. Okay, but interestingly, there is something of a linear pattern in the very beginning, but then things kind of go awry somewhere around here, and we'll explore that. So you may be tempted to fit a linear model to this, but if you were to fit a linear model to this, there would be a pattern in the residuals. And that's what happens when we have data that look like this, that look sort of linear, but really, if we're going to be honest, the data are rather curved. And lo and behold, right on cue, a bad residuals graph. So here's a graph of the residuals against the duration of the dive. It's the same x-axis variable as before. It's how long the penguin's under the water. But these residuals are actually starting out okay. There is a point at which a linear model would be okay, but past that point, once we get past around 4 minutes, there is a very clear linear pattern in our residuals. This makes for a good segue into the topic of extrapolation. The data on the penguins show us that there are times in which a regression line is helpful, say to about 4 minutes, but past a certain x value, a regression line becomes less helpful. Now, even if the data on the penguins were good for a linear model, we still need to be careful about how liberally we use our regression line as a predictive tool. Knowing when not to trust a regression line is important when discussing the topic of extrapolation. Okay? Extrapolation is usually a risky move in statistics. Extrapolation is when we use a regression line, good predictive model, to make predictions for high values of the x-axis variable. This is opposed to interpolation, in which we use the regression line to make predictions about x values in the interval we're studying. So in general, the further we get from the mean x value in our data, the more dubious a regression line becomes. And once we've left the range of the x values, predictions should be made sparingly and with discretion. So this is an example from the textbook of how extrapolation can go very, very, very wrong. In the 1970s, the price of oil started going up. Statisticians fit a trend line to their data from 1970 to 1982 that's linear and with no clear outliers and seems fairly random. We have some points below the regression line, some points above the regression line, some points very close to it. But it seems like data that may be suitable for regression. and we come up with this linear model, and we're all happy. So now we can make guesses on the price of oil after 1982, right? Right? No, we can't. What makes this even more interesting is that they tried the same technique in 1998 and 1999. You can see AE098 in the green and AE099 in this purple, and things didn't go quite as planned either. I mean, here's 1982 over here. They could have learned back then that this was not a winning strategy, but they didn't. They tried again, and they were almost more wrong on both occasions. Note the things that happened in the years that weren't so well predicted. You have tensions between U.S. and the Middle East, China's economic boom into the 2000s, things that really you could not predict that are going to change the price of oil. Any conflict between the U.S. and the Middle East is going to make oil prices do interesting things. China's economy really took off from the 90s into the 2000s, and that made for a major demand of oil, and that's going to break your regression line there. Also, there's a sharp downturn in 2008, and we know what happened in 2008. There was a global recession. So regression lines fail over time because of the increased likelihood of, ironically, unpredictable events. So now we're going to try this for ourselves. We're going to take these statistics right here, and we're going to make a regression line and see how it compares to the real-world data. The U.S. Census Bureau reports the median age at first marriage for men and women. Here's a regression analysis of median age at first marriage for men against year since 1890 at every census from 1890 to 1940. And we see some promising things here. R squared especially 92.6%. And a typical residual size of 0.2417, all right? Considering the nature of what we're studying, that's a pretty low typical residual size, and that's a pretty awesome R-squared value. So we're going to go in with the assumption that these data that we collected that we don't know, but we know a bit about them, are conducive to a linear model. So we're going to find the equation of the regression line predicting the median age at first marriage of men against year from 1890 to 1940. Give it a go yourself. Use these statistics right here to do it. Unpause the video when you're done. Okay, I'll assume we're ready to go. So we're predicting age, and we take the intercept, 26.07, substitute it there, minus 0.04, that is my slope of my regression line, the coefficient of year, all right? And that's year since 1890, not year since, I don't know, the first year. Now we're going to predict the median age at first marriage of men in the year 2000. 2000 is very far away from 1940. If you have been on Earth for as long as you have, you know that a lot happened between 1940 and 2000. Even though you weren't alive, and I was barely alive, let's make a prediction. See how we do. The model predicts the median age at first marriage for men by 2000 is 21.67. All right. So we are marrying pretty young in the year 2000. Nope. We're not marrying young in the year 2000. We're clocking in at an average first marriage age of 27. Okay? So in the year 2015, we take that out even further, things get even more wrong. the median age at first marriage was 29.7 years. This model is so atrociously wrong after really 1960. Well, what happened? So this is not the complete story, but it's a big part of the story. Let's do a little history lesson. We're going to go back to 1900. We have a new century on our hands. All right, here we go, 1900. Uh-oh. 1914. What happens in 1914? World War I begins. A couple years later, the U.S. is in World War I, and you'll notice that dip right here. We're kind of steady Eddie into the new century, and whoa, we take a little bit of a nosedive here. In uncertain times, generally, people are quicker to get on with big life experiences like marriage. And so in uncertain times, big military conflicts, the war to end all wars, the age at first marriage for men is going to go down a bit. And then after World War I, you got the 1920s and things kind of even out. And then, we're going to start going down again. And right around here, we hit World War II, U.S. involvement in World War II. And so we take a pretty big dip right here. That is the 4 or 5 years into the U.S. involvement in World War II. And the number starts really going down. We're really trying to get on with these big life events. And this trend continues in the post-war optimism until the late 1950s, and things start to turn around. The further we get from major military conflict, Vietnam was somewhere around here, so that might have slowed down the progress. But the further we get from major military conflict, as people begin to settle, things become a bit more certain, time goes on, people are more apt to put off big life events like marriage. And obviously that's not the whole story. There were some major changes around here that affect things going forward, I know. But in general, you can see a major pre-war, during war, post-war difference. And a regression line's not going to know that. So there you go, little history lesson within statistics.